Hey, what's up, guys? Chung here again. And so this time I want to talk about a different LeetCode problem here. So, which is number 914, X of a card in a deck of cards. It's an easy problem, but I think for me, it's more like a medium problem because there's something that I didn't know before solving this problem. Okay, let's take a look. So you have a deck of cards, and each card has an integer written on it, and return true if and only if you can choose hmm, x is greater than 2, such that it is possible to split the deck into one or more groups that cards where each group has exactly k cards, and all the cards in each group have the same integer. Okay, so what does this tell us, right? Basically, you have different numbers here, right? And it asks you it asks you if you can split all those numbers into like any group, right? Basically starting from one or more into any group. But among all those groups, the size of those groups has to be the same, and each group need to have the same value, right? So for example, this is the first one. It can be split into four groups, right? Oh, and sorry, and each group's the value has to be greater, yeah, like at least two elements in each group. So for example, this one, there are like it can be split into four groups here. So one, one, two, two, three, three, and four, four. So the lengths are the same, and and each element in this group are also the same. So for this one, no, we can't, right? Because 111 is a group, 222 is a group, but 33 is not, right? So that's why it cannot be split. And this one, even though if we can, all the elements in the groups are ones, but we need this element in each group at least two. This one is fine because the uh, the group can be one or more. So in this case, there's only one group, and in that group there's one here. And a different example is this one here. So we have 1, 1, 2, 2, 2, 2, right? Basically, this 2 and can be split into three groups, even though there are like four twos here. But we can split those four twos into two groups of two, so that it can make this three groups, right? Okay, so you guys can see, right? Even though it's a simple, it's easy problem, but the accepted rates is like only around 30%. Okay, right? So how do we solve this problem, right? So I think the first thing come to my mind is that we have to do a counting, right? We have to count each of the unique number, the numbers, each number's count appearances, right? And then we have to somehow use those countings to come up with our result, right? For example, here, let's say, so in this case, that's the easiest case, right? So the count for one is two, for two is two, three is two, right? That's the easiest case, right? And then this is fine. And another case is like one is three, two is three, three is three, right? So this is also a valid point, a valid split. And then it comes to a more interesting part here. So let's say there are like two, uh, one is two, right? Two is four, and then what? Three is what? Three is eight, right? So this is also can be splitted evenly, right? Because even though two, we can split basically these two into two group of two here, and three, we can split the three here into four groups of three, right? So that this will also be a valid split. But let's take out this one. One is two, two is six, 3 is, sorry, 2 is 4, 3 is 6. Well, actually, you're right. So this is also a valid one because we can split. Hmm, we can split this 3s into 3 groups of 2s, right? So this is also a valid one, right? This is also good. And now 1 is 2, 2 is 4, 3 is 7, right? Then obviously this is not a valid one, right? So with this kind of combination, so what kind of like techniques we can use here, right? So this problem is more like a math problem. You guys must have already have learned this concept called greatest common divisor when you were in school, right? So I think the technique here we'll be using is once we have all the countings here, right? Basically we'll be getting getting the basically the common the greatest common divisor for each of the those two values. For example, here, right? So 2 and 4, the common divisor, the greatest common divisor is 2, right? And every time when we have an updated one, we use this updated one, try to do another greatest common divisor with the next count here until we have until we loop through all the counts here, and in the end we simply check the current divisor, right? That's a and this is the greatest common divisor if this one is if it's greater than 1 or not, right? Because for let's say for example this one here, right? So let's say for 2 and 4 we have a common greatest common divisor equals to 2 here, right? And then 2 and 7, right? How about 2 and 7? It's 1, right? Because we cannot split evenly, right? For between 7 and 2 here. That's why as long as so basically in the end we just check if the update if the last uh basically if the common divisor for all the sorry, actually it should be the common divisor, the greatest common divisor among all those values, right? If the value is greater than 1, then we know we should return true. Otherwise, if it's 1, then if it's 1, then we know we can't. Then it's false, right? Yeah, for example, this one, right? So the greatest common divisor for this one is 3, right? So this is 4. This is 2. So a few more cases. Let's say there's 6 and 9. Uh, right? How about this one? So the greatest common divisor is 3, right? And then more here, like 6 and 12, right? That's same thing here, this 6, right? So basically all we need to know to check is among all those counts here, the common divisor, the greatest common divisor for all the counts, if it is greater than 1. If it's greater than 1, true, otherwise false. Cool. All right. So, okay, so with that being said, let's do the coding part here. So I'm gonna have a counter, right? So I'm gonna use the Python's collections libraries here. So it's gonna which will have as a counter built-in method here. I basically just check in, pass in the stack here. What this one does is basically it will count everything, and it will generate a dictionary here. And then the current divisor GCD, okay, current greatest common divisor equals to 0, right? And then basically we're gonna have like 4 count in counters dot values, right? So current GCD equals to the get GCD, okay? A and B. Sorry, the count and right current GCD and the count, right? So in the end, we simply return we check if the current GCD is greater than 1 or not, right? And now all we need to do is to define helper functions to help us calculate the greatest common divisor for those two values, right? So there are a few ways how you can do it, and one of the algorithm I'm using here is I'm doing the mod, right? So basically um, while a basically while any of them is not zero, because one of the special case for this like GCD is that let's say we have a 0 and 3. So what's the greatest common divisor between 0 and 3? The greatest 3, right? Right. And basically basically as long as there's a like there's a one zeros, we have to basically we'll be returning the other one, right? This could be a 100, right? So because 0 and 0, there's no um because it's I think that's the definition of the greatest common divisor, right? Between 0 and 100, it should be 100, right? Because 0 divided by 100 it's also 0, right? And same thing for this 100, do a mod 100 is also 0. That's why we are for anything with a common divisor with zeros, it's this number itself. Okay. And since we're using like the mod here, right? So that's why basically if a, that's why I'm doing this. Like I check if any a or b is zero or not. Basically, I'm doing a times b to help me to check. As long as either one is zero, I just stop the while loop, right? Because I'm going to use like a division operator here. Basically, if the a is greater than b, I do I do a mod, right? I do a mod with b, sorry, and b, right? Else if, right? Else if a smaller than b, right? I do a b is a, right? So here and also and a is not equals to b, because when a equals to b, then we need to stop, right? Basically, if a is the same as b, then we simply return either a or b. Okay, so and then here we simply we return uh, we return a if a is greater than b, else b, right? So basically here I'm covering two scenarios. So first is this one. Okay, so I think for this one it doesn't really matter. I think I'm only checking if a or either a or b is zero. I just need to return the other one. Okay, basically if a is zero, and I'm basically I'm returning b here. Okay, yeah, cool. Okay, let's try to run this code here. All right, and submit. Yeah, so pass. Basically, it's a math problem. I think why I decided to make a video for this one is because of this get greatest common divisor. I I didn't know this, like I didn't know how to get this one before solving the problem. That's why I wanna maybe make videos for you guys. And for any of you who didn't know this kind of how to calculate the common divisors, and yeah, you can use this mod algorithm to to calculate that, right? So okay, cool guys. I think that's it about this problem. Thank you so much for watching the videos and stay tuned. See you guys soon. Bye bye.